types of adsorptions. Number one, known as physisorption, and other is known as chemisorption. Now, what is physisorption? When the gas is held on the surface of the solid by van der Waals forces, which are the weak intermolecular force of attraction, without resulting in the formation of any chemical bond between the adsorbate and adsorbent. It is called physical adsorption or van der Waals adsorption or physisorption. There are the certain characteristic points that we must remember in the case of physical adsorption known as physisorption. These are physical change. It is simply the physical change and no chemical bonds are formed. That is why it is called physical adsorption. No specific nature, as the van der Waals forces are the universal forces. On every solid adsorbent, every gas is adsorbed. Only to the extent of adsorption may vary. They show that it is non-specific in nature. Third, the nature of adsorbate. As it is already explained, easily liquefiable gases means the gases which are having high critical temperature are adsorbed more strongly because they have the stronger magnitude of van der Waals force of attraction. Reversible nature. The physisorption is the reversible process. Now, if we increase the temperature, physisorption decreases. Low enthalpy of adsorption. As we know that in physisorption, the enthalpy of adsorption is very low, which vary from 20 to 40 kilojoule per mole. Now, when the gases molecule or the atoms are held to the solid surface by the chemical bond, then the adsorption is known as chemical adsorption or chemisorption. Now, in case of chemical adsorption, we know that there is a formation of the chemical bond, which may be the covalent bond or ionic bond. And due to this formation of the chemical bond between the adsorbate and adsorbent, the adsorption is known as chemisorption. Now, in chemisorption, the chemical bonds are formed sometime when the two processes occur simultaneously, and it is not easy to ascertain the type of the adsorption. A physical adsorption at low temperature may pass into the chemical adsorption as the temperature is increased. For example, the dihydrogen is first adsorbed on the nickel by van der Waals forces. The molecule of the hydrogen then dissociate to form hydrogen atom, which are held on the surface by chemisorption. Now, what are the characteristics of physisorption? The characteristics of physisorption is lack of specificity, the nature of adsorbate, reversible nature, surface area of adsorbent, and enthalpy of adsorption. As we have already discussed about the lack of specificity, at a given surface of the adsorbent does not show any preference for a particular gas, as the van der Waals forces are the universal forces. The nature of adsorbate, the amount of the gas to be adsorbed by the solid depends on the nature of the gas. Easily liquefiable gases means the gases having high critical temperature, they are readily get adsorbed by the van der Waals forces. Reversible nature, the physical adsorption of the gas by the solid is generally reversible. More of the gas is adsorbed when the pressure is increased, as the volume of the gas decreases and the gas can be removed by decreasing the pressure. Since the adsorption process is exothermic, the physical adsorption occurs readily at the low temperature and decreases with increase in temperature according to Le-Chatelet principle, as we already know this. The surface area of adsorbent. The extent of adsorption increases with increase in the surface area of the adsorbent. Thus, finely divided metals or the porous substances having large surface area are very good solid adsorbents. Enthalpy of adsorption, as we have already discussed that the physisorption have very low enthalpy of adsorption, vary from 20 to 40 kilojoule per mole. This is because the attraction of the gaseous molecule on the solid surface is only due to the weak van der Waals forces of attraction. Now, what are the characteristics of chemisorption or chemical adsorption? As we know that the chemical adsorption have the high specificity Chemisorption is highly specific and it will only occur if there is some possibility of the chemical bonding between the adsorbate and adsorbent. Irreversibility. As chemisorption involves compound formation, it is usually irreversible in nature. Chemisorption is also an exothermic process, but the process is very slow at low temperature on the account of a high energy of activation. Like most chemical changes, adsorption often increases with rise in temperature. Physorption of the gas adsorbed at the low temperature may change into chemisorption at a high temperature. Usually high pressure is also favorable for the chemisorption. Now these are the surface area. The physical adsorption, the chemisorption also increases with the increase in the surface area. Enthalpy of adsorption. Enthalpy of chemisorption is high, vary from 82 to 40 kJ per mole, as it is already explained due to the formation of the strong chemical bond between adsorbate and adsorbent. Now here, these are the differences between the physorption and chemisorption, which always ask in their board examination, what are the basic differences between the physical adsorption and chemical adsorption. Now, in physical or chemical adsorption, first, the force operating, in this case are the van der Waals forces. Chemisorption means the force operating are the chemical bonds. The heat of adsorption is low, vary from 20 to 40 kJ per mole. The heat of adsorption is high, vary from 40 to 400 kJ per mole. The process is reversible. The desorption can be occurred by increasing the temperature or decreasing the pressure. In chemisorption, the process is irreversible and efforts to free the adsorbed gas have different compounds. It is not require any activation energy, while chemisorption requires high activation energy. It takes place at low temperature and decreases with increasing temperature, while chemisorption, it takes place only at high temperature. This type of adsorption first increases with increasing temperature, and then after a certain limit of temperature it will start decreases. It is physorption, it is not specific for the nature of all the gases, while chemisorption it is highly specific. In physorption it increases with increase the inner surface of the adsorbent. It also increases with the increase in the inner surface of the adsorbent, while physorption it forms multimolecular layer. Chemical adsorption always forms unimolecular layer. The another difference that we observed between them is the amount of the gas adsorbed is related to the ease of the liquefaction of the gases in physorption, while there is no such correlation in case of chemisorption. Now, what are the various factors which affecting the adsorption of the gases by a solid? There are the various factors like nature and the surface area of the adsorbent. Nature of the gas being adsorbed, temperature, pressure, and the activation of the solid adsorbent. These are the various factors which generally affects the adsorption of the gas by the solids. Now we describe the first one, that is the nature and the surface area of the adsorbent. It is generally observed that the same gas is adsorbed to the different extent by different solids at the same temperature. Greater the surface area of the adsorbent, greater is the volume of the gas adsorbed. It is for this reason that the substances like charcoal, silica gel are the excellent solid adsorbent, because they have highly porous structure and their surface area is large. Second, the nature of the gas being adsorbed. The different gases are adsorbed to the different extent by the same adsorbent at the same temperature. This will depends upon the critical temperature. As we know that higher the critical temperature, more easily the gas can be liquefied, greater are the intermolecular force of attraction. For such a gas, greater will be the attraction of the gaseous molecule on the surface of the adsorbent, and hence greater will be the adsorption. This generally represents that higher the critical temperature, more will be the ease of the liquefaction of the gas, and more of the gas will get adsorbed over the surface of the solid adsorbent. Third is temperature. As we know that the adsorption is an exothermic phenomena. Whenever the gas gets adsorbed over the solid adsorbent, then the heat is evolved. The amount of the heat evolved when 1 mole of the gas is adsorbed on the solid adsorbent is called the enthalpy of adsorption. So, the studying of the particular gases by some particular adsorbent, it is observed that the adsorption decreases with increase in temperature and vice versa. This will take place in the case of physical equilibrium, physical adsorption. Like chemical adsorption, it first increases by increasing the temperature and then it starts decreases. The next factor is pressure. At constant temperature, the adsorption of the gas increases with increase of pressure. It is observed that at the low temperature, the adsorption of the gas increases very rapidly as the pressure is increased. The activation of the solid adsorbent. Now, in case of the activation of the solid adsorbent, it means that increasing the adsorbing power of the adsorbent, which is usually done by increasing the surface area of the adsorbent, which can be done by making the surface of the adsorbent rough, or by subdividing the adsorbent into the smaller pieces, or by removing the gases which are already adsorbed over the surface of the solid adsorbent.